So we're now going to talk about how parallel programs are developed in Java using modern Java, so-called modern Java features. In particular, we're going to talk about something called parallel streams, which is a synchronous parallel functional programming framework. And we're going to talk about completable futures, which are an asynchronous parallel functional programming framework. So those are the two different variants. And this came out with Java 8. Interestingly enough, as we talked about just a minute ago, both of these parallel functional programming frameworks leverage the object-oriented fork-join pool framework by default. And that works fine because the fork-join framework is quite efficient. It was just hard to program. So you can think about these other frameworks as kind of encapsulating the more complicated object-oriented programming with the more convenient, civilized, if you will, functional programming framework. So again, two frameworks. First one we're going to look at is parallel streams. And what parallel streams does, we'll use in the context of a little example, which you can read about, or you can actually look at all the source code here in this package in my GitHub repository. It's called Image Stream Gang. And this particular program will take a list of URLs to images that could be out in the web somewhere. And it checks to see if the image is already cached. If it's already cached, it ignores it. If it's not already cached, it goes ahead and downloads it, applies filters to transform it, and then stores the images, and it does this all in parallel. So if you've got 100 images to download, this particular program will download 100 of them in parallel using Java parallel streams. So what parallel streams does is it takes a stream, like a stream of URLs, and it partitions it up into multiple chunks that will run independently on different threads, of course, processor cores, and then allow those things to be combined together into a single reduced result, which in this particular case would be the list of processed and stored images, or filtered and stored images. The chunks of data that are processed in a parallel stream are transparently and efficiently mapped onto the underlying threads in the common fork join pool, which of course in turn maps to the underlying cores, and everything runs in parallel. And what's super cool about this, and you will get a chance to learn about this firsthand, is all this stuff happens without much programming effort on your part at all. It's really cool. So once you understand the streams model, doing parallel streams is quite simple. And as I mentioned, the common fork join pool is leveraged under the hood, which is a great example of systematic reuse. We don't have to rewrite that code ourselves. We get that code out of the box from Java 7, and then other generations of Java can leverage that stuff. Parallel streams can be thought of as providing fine-grained data parallelism for functional programming. So you get a parallel functional programming model that's fine-grained, which is in contrast to the more coarse-grained approaches done with earlier versions of Java, like the Java Executive Framework. This model is very straightforward to understand. Once you understand the concept of functional programming, once you understand the concept of sequential functional programming with the streams framework, which isn't too hard to master, we'll cover that starting Wednesday, then going to parallel streams is usually as trivial as just going from .stream to .parallel stream. It's ridiculously easy to do. There's another model, however, which is not quite so easy to master, but is very cool and sometimes more efficient, called Completable Futures. And this particular example, which you can see here in this sample code in my image counter folder, will count the number of images in a recursively defined folder structure using a whole pile of features in the Java Completable Future framework. So what Completable Futures do is they support dependent actions that are triggered upon the completion of operations that were invoked asynchronously. Now you're probably like, what the heck does that mean? And you will get a very deep understanding of this by the time the course is done, because you get a chance to program it. But in a nutshell, here's an example. So let's say we want to take a link and to some website like CNN.com or ESPN.com or whatever, and you want to traverse it and find a count of all the different images that are available, reachable from a starting point. So think of it like a web crawler. So you can start out by getting the start page asynchronously, so get me the contents of ESPN.com or whatever. And then you will then have what's called a completable future, which I think of as like a table tent number. If you ever go to a fast food restaurant and you order something, they'll say, we'll cook it for you, we'll bring it out to you. And they'll give you like a little token. Back in the day, they'd give you a plastic token called a table tent number. Nowadays, they're more likely to give you a piece of paper with a number on it. So whenever your order is done, then you get it delivered to you, or you can go pick it up. So what happens is we start the asynchronous downloading of a web page, and then we can split at that point. We can fork to two different subtasks that run in parallel. One can go and asynchronously count the number of images on that page, and the other can go ahead and asynchronously traverse all the links on that page, and then count the number of images on each of those pages. So all this stuff can take place asynchronously, and then as all the asynchronous computation completes, we can combine the results together and sum the results. So this is basically kind of a data flow, asynchronous data flow, workflow style processing model using these things called completion stages. And we'll talk a lot more about that as we go along. The asynchronous operation model, it's a concurrent programming model where the caller doesn't block waiting for the callee to complete. So you initiate the operation, you get back what's called a completable future, and you can go on and do other things, and then you can wait for stuff to happen when the asynchronous operation is complete. Super duper cool model. Completable futures also can leverage the common fork join pool. So you can use completable futures to support asynchronous parallel processing. I like to think of asynchronous parallel processing as kind of like juggling. The idea with juggling, as you know if you're a juggler, is to keep as many balls up in the air as possible and only hold them long enough to transfer your hands and throw them up. Or if you're really good, in one hand, you can throw them back up again. But the point is that you don't keep the balls in your hands synchronously. You try to get them up in the air as quickly as you can. And that's kind of the way that asynchronous computations work with completable futures. So now that we've given an overview of Java parallel streams and the Java completable futures framework, let's go ahead and take a look at the pros and cons of using these techniques. We'll start with the pros. One of the benefits of using Java's parallel functional programming frameworks is these frameworks perform well, especially on multi-core processors. They give you good performance while also enhancing developer productivity. And you can see on this slide, there's a nice balance between making the computing hardware work effectively, to run fast, to be scalable, to have good throughput, low latency, and so on, while also at the same time making it easier for people, mere mortals, to build parallel software, which is sometimes hard. In the past, it used to be the case that you could make things that were easy for people to program, but they wouldn't perform well, or they would perform well, but people had a hard time programming them. Another thing to note here is both parallel streams and completable futures encapsulate object-oriented programming a la the fork join framework with nicer, easier to program parallel functional programming facades, using something that you might be familiar with from earlier courses such as the facade pattern from the Gang of Four book. Another nice benefit of using parallel functional programming frameworks is that explicit synchronization and threading is rarely needed when applying these frameworks. You don't have to put locks in your code often because of the way that the partitioning takes place. You don't need to spawn threads directly. Those things are handled for you, typically by the underlying fork join framework. And this capability helps to alleviate many accidental and inherent complexities of concurrent and parallel programming. As I always like to say, not everything is rainbows and unicorns. There are some downsides to these approaches. One of the challenges with parallel streams and completable futures when either used in isolation or even when combined together is they don't fully integrate the stream model with asynchrony in order to achieve the goals of the so-called reactive programming paradigm. And we're going to talk a lot more about this paradigm here later in the course, but in a nutshell, reactive programming is involved with four main principles. Responsive, meaning that you give things with low latency. Resilient, which means that if partial failures occur, the system continues to operate. Elastic, meaning the ability to scale up, to auto-scale over time. And message-driven, which is really more about the concept of loose coupling between the components in the system. So needless to say, in order to achieve this better integration of streams with asynchrony, that's going to motivate the need for other Java frameworks, in particular Java reactive streams frameworks, which integrate streams and asynchrony more intentionally than you get by using parallel streams and completable futures together or in isolation. So we'll be talking about some of these frameworks such as Project Reactor and RxJava later in the course. So that's the overview of how you can develop parallel programs using Java, modern Java features like, again, parallel streams and/or completable futures.